Hello, guys. I will start with the presentation about me. So my name is Marc. I'm coming from Spain. I'm a principal engineer at Airalo. We are like a eSIM retailer application. And for context, why I decided to do this topic is because basically we had in the face this basically moment where we needed to scale our application. We basically grew up pretty recently. Let's say the past 3 years we have been facing from state of the art where we find out this AI topology where basically everything is going up. We got ChatGPT, we start getting auto-completion, we get that kind of tooling where we are improving our way of working, but we still have facing this kind of sea of uncertainty where we are, what we are doing, this is helping, but what's the point of it? Then your application is growing at a scale. You basically grow so big, so fast. AI is working at the same pace. So we transitioned from a startup level, from a enterprise level. We recently became a unicorn with basically the goods and the bads. This means that more bureaucracy, less freedom to work on what you wanted, how you wanted. So this means AI also needs to be bureaucratized somehow. I just prepared a small quiz. I just feel curious about who is actually using AI coding right now. Just slightly raise your hand if you're doing. Okay, fair. The second level is how of that people are you really setting up specific rules, or are you just vibing? So who is just working on actually working on a proper setup of their architecture? Okay, like 20% of the people who said yes. Nice. And the third point is like, from those people who had to set up, you did it for a reason, right? It's basically because you realize that at the scale, the project is not growing as you expected. So you keep asking the AI what to do, the context grows, the cost grows, the difficulty to the AI to basically complete the task also gets bigger. And at the end, probably creating some frustrations like that's not working. So we wanted to deal with that situation of AI is not useful because we are so big. And that we faced, and we basically managed to solve it. And I will basically expose more or less what we are doing, what's working, and how we managed to make it work. So the challenge, that's probably the most the most probably topic that we want to discuss. It's like why we need a proper architecture. What's the issue we faced? We need to understand that when we are using AI, it doesn't scale properly as the project grows. This means that we consume tokens. The bigger the conversation gets, the most hard is for AI to keep up, but the harder is it. So we had like our last speaker, Matthias, who is actually working with me, who spoke about context consuming. And one of the situations we faced is that you are working toward your project, you are creating your tests. We will talk about this slightly on the topic. You are trying to explain the behavior you want the application to do, the AI to do, sorry, and you keep up on evolving this. What happens? First iteration, you expose the problem, it generates the code, maybe it doesn't work, you keep up onto the same conversation, you keep iterating, but what AI is doing under the hood, I don't know if any one of you have tried to develop an internal agent under the hood, but basically the agent keeps the whole history of the conversation as a context. So every time that you add a new prompt, it's adding all the previous prompts, all the previous solutions onto the context and adding your next one to the context. This means that it scales mostly exponential because it's adding all the time the same thing n times. Sorry, I'm getting used. So let's start from the basics. There are two main approaches on a higher level that we worked on the project. And just a small disclaimer, all these slides have been generated also from AI with some kind of tweaks from my end to basically being formatted. And the interesting things that they have been generated within the template project I've been using to demonstrate everything. So if everyone feels curious about it later on, I can just send an email with the template and have fun for it. The interesting thing is that we had two layers of working with AI, project level and company level. What means? I'm working onto the Android division, so we have been working towards making a specialized AI working on our project, but we recently have been also investigating how can we work on making it work towards the other divisions. Example. Few days ago, sorry, I'm just getting confused with the previews and the next pages. Okay, cool. That's what we have. Basically, we have a parent workspace dedicated. Normally, you have your IDE into your generic project folder. We just went one step further and created a company workspace where we basically put all our projects in it, let's say backend, front ends, dedicated libraries, if any. For instance, we also have a SDK dedicated to the network layer that basically can be shared across clients. Like for AI, it's very convenient. And what we did, and here it comes, is an experiment where we took just a very small bug fix task that happened recently. We were working onto a export data from the clients because for compliance, and we had to implement a new throttling system where the backend just implemented a new error code that we needed to manage, and we forgot to add. What happens? Normally in this kind of situations, and the bigger the company, the harder it is to communicate with every stakeholder to understand what happened, how happened, and then who fixes or how to fix it. But in this case, we just needed to understand that we had a Jira ticket. We had an MCP server that basically fetches the Jira tickets. We just needed to know which is the Jira ticket that this task was implemented on the backend, UXP 1, 2, 3, 4, 5. And on the agent, we just needed to say, please search on the backend project origin commit with this Jira ticket as a name, generate a summary of what it was implemented. Please find the project on the clients that can be potentially implemented this fix and do it. And in fewer steps, it did. So first step, went to the backend, fetched and searched for the origin that implemented the feature. It was just a simple, we had a new 4 of 9 conflict with this specific error code that you can manage to parse into your client. Then, as I said, we have an SDK for the multi-platform layer, and then it found out that the SDK was missing to parse this generic error. It just fixed and created a commit. The rest on our end, it's basically creating a PR, waiting for it to be accepted, merge, and so on and so forth. Could be automated, maybe, but we didn't yet. Fair enough. Okay, so I will start down describing the project level structure. From now on, I will focus more onto one dedicated project. It's basically our daily basis way of working. Disclaimer, everything that you see here tries to be platform agnostic, so I'm not working towards Claude Code, Copilot, or Gemini, etc. Mostly because at our company, for instance, we work towards different kind of AI frameworks, so we rely slightly also on providing context manually at the moment, and we are evolving towards improving that process. So we have this AI folder that it could be Copilot, Claude, the typical generic guidelines one that everyone explains. I will go deeper on every of the topics, by the way. And we have also a prompts folder. This is very important because AI normally can get all the context from the project, but the bigger the project, the harder to get the context and find it. We will work towards how to improve AI searchability for every feature, for every specific dedicated task, but having prompts that help out the AI to keep up with dedicated things that we want to do, like creating a view model, testing a view model, creating a feature module, or testing like end-to-end HTTP, etc., etc. So we keep them there to basically add them as a context for every dedicated feature that we want. Later on, we have a core and feature parent modules, where core, let's say, it's more like a dedicated shared infrastructure for the project, like the database setup, the design system. I forgot to put a README into the AI folder, so forgive me. But README is something that we realize it's very useful to add everywhere, even as a parent or as a sub-level, because even if the AI won't take them always as a context, it's important, as I said again, to manually add as much information as you can for the task that you want to do. And at that point, it's very important if you are able to do it for him. So saving tokens, saving time, disallowing the AI to basically search for all the code base is something very, a good practice, let's say. Yes. So let's go for the AI folder. As I said, one of the primary things that we have is the guidelines and the prompts. This is a division of mostly what we have. I added the memory option there. I will go towards MCP tools and techniques that we use to basically give the project memory at a personal or a team level. But memory, I would say, is one of the key things of the project. Why? Because probably if you used AI, sometimes you just realize that from session to session, AI doesn't remember anything. So you or either save something as a context to continue working. There is this pattern of the planner that basically you create an MD file with a task list where you basically split a task into a plan and you keep the evolution of the development of a feature towards the AI through this plan, or you use some techniques to basically allow the AI to keep up on the progress. We'll come in short. Okay, the guidance. I don't expect you to see anything. That was a short example, but basically guidelines is a very hot topic nowadays. They used to say that you have to add short descriptions to what you want the AI to do for you. And that's true. We tried several ways of creating guidelines from a very large, dedicated, super concrete, and with examples guidelines to try to see if AI can follow up. Long story short, don't do it. Because that reason, AI is basically attaching the context every time. And guidelines, it's a special file that AI or the agent is attaching every time. So if you are attaching every time, not only at the beginning, but at every time that you are speaking and the file is super big, you are probably consuming hundreds of tokens that they are not needed. But what it works indeed is creating a very short guidelines, not only with code styling or structures like, I don't know, please use functional libraries, use the SDK instead of creating your use cases, or test with TDD, or don't use mocks, use fakes, please, etc., etc. That's fine to use it, but we'll come later to it. We want to specify the AI how to behave with tools. And tools is very, very useful. We are talking about tools like MCP servers, like bash scripts that we generated, or any kind of integration to agent protocols, etc. So we are basically splitting responsibilities and understanding from the AI at a deferred time. So basically we are telling the AI what it has to call when it needs it, rather than providing the whole context at the very beginning. This is very useful because sometimes you don't even want to create a test for a refactor of a composable if you are on Android, for instance. You just want to change some UI and perhaps run the code and verify that the application don't crash. It's like a silly example, no? So that's what we aim with with the guidelines. So the second part, it's like tooling in composition with what I explained, with the guidelines. Here I'm showing two of my favorite ones and demonstrated that they work. These are native MCPs from Claude, and they are free to use to any kind of agent, so they are not specifically to Claude. But memory graph is related with the memory folder I told you. This MCP basically creates a JSON-like structure that basically writes down every time that you ask to, and this is very important to basically write it down into the guidelines. Please write onto the memory graph every time that you perform an action, but also read the memory graph before you perform an action. And the memory graph is just a tree node, to understand it somehow, made in JSON, where it creates actors and entities. And actors can be you as a developer. You can instruct the MCP to say, hey, I'm Mark, I will work into that project, so please, when we speak, just remember I am. And you are working into this project, Airalo, in my case, for instance. Then it will just keep writing what I did, what I asked, what the outcome of the agent was, what was my feedback, etc., etc. This is very useful because it allows me not only myself to work with the AI, but also if we share that file, my colleagues to know what I did and how I did it, so they can also work on features that depend on what I did. That's very powerful. And there are two levels. You can do global laptop, local setup, or also project shared setup. Up to you. The second one, okay, well, yeah, I split here because, as I said, this is AI generated, and dealing with the format was very, very hard. So I just had to split. But it's what I said already. No, okay, sorry, that's the second one. Sequential thinking. I don't know, does someone work with Junie? Does someone try it, more or less? Okay. Junie does something very great, that's planning. And normal agents like Copilot, Claude, or whatever else that you have been tried, normally are meant to perform a task over a prompt. You say, please perform this because ABC reasons, take in consideration guidelines, take in consideration this prompt, etc., etc. So they try to write the code, they try to perform the action, find an outcome, and then return it to you. Planners used to take several steps, multiple steps and iterations over the execution. So they are not meant to perform a single change or a composite change of code and return you an output, but they actually loop in the cycle of generating code, the loop onto the idea of understanding the code, generate a plan, stick to the plan, and perform a step execution over it. So sequential thinking aims to solve this problem from agents who are only meant for executing a single task. So it performs this cyclic tool or cyclic or rational thinking to perform a plan and stick to it. There are other tools that already do it, like Claude, and we are in love with it. It's work amazing. But this basically bypasses or helps out to basically keep up onto this cyclic evolution for every tool. That's really, really helpful. And generative prompts. That's the folder that I showed you before. We have, and probably you have, many different type of patterns, like how are you creating use cases? How are you creating your caching strategy or network strategy for your endpoints? How are you testing? How are you testing your view models or your UI if you are testing your UI, etc., etc. So we split every dedicated task that we want to use on specific tasks to a prompt. So we manually used to select this prompt to understand that we want to perform a view model implementation, or we want also to test it, or we need to use the SDK that I mentioned before to call specific actions, etc., etc. And this decouples the guidelines, as I explained before, to the concrete execution. That is the, I'm going to switch to the core modular structure. I'm not going to go deeper into the configuration of the database or utils. That's mostly for demonstration purposes, like a regular core project works. But I want you to notice the README. Having READMEs at a parent level that works out as a shared documentation or a holistic documentation on what every subcomponent does, it's very helpful for the AI. And stating into the guidelines that they should read the README before going into the code actually works. Because it's not the same reading a README of probably 100 lines that reading 5 folders of probably 20,000 lines in total. At the end, as I said, the context is important, and also the tokens that you consume. One of the most interesting things to comment about is the design system. There is a pattern. I know that this everything sounds like good practices for development, but they are for a reason, and they pay out lately. So it's double as good. It's good for humans, it's good for AI. There is a common pattern called atomic design that basically tries to split the components into different sizes. Let's say atoms, molecules, and organisms. There are like bigger ones, but we believe that it's enough for the specific design system to take these ones. We can understand atoms as the very, very minimal elements on a UI component. Let's say labels, let's say text, let's say buttons, let's say radio buttons, something like this. We can consider the molecules as small components, but they are formed as compositions of atoms. Let's say a search bar that can be basically maybe a text field plus a button and some icons to modify the state. And then we have the organism that can be something on top of the molecules, like a top bar or a drawer menu or some kind of more complex menu, but don't per se being a screen. There is also like the screen component, but it's more like a feature-based, let's say, component on our point of view. So we just prefer to keep the design system lean and being able to be reused. There is some important thing, and you realized already from what I'm explaining, that helping the AI to search, it's a very good optimization. And in this case, we are using a prefix. So our design system is called Trek for no reason. We just liked it. And this means that AI can ensure, you will ensure that AI will search for a Trek prefix, because running a command in the terminal, just finding all the components, makes it fast. So you don't actually need the terminal to go to the AI, to go into the design system file, iterate over all the files, and try to read all the content and try to basically understand what it has. But instead, having to grab into the Trek, finding all the components, and of course, we need the README that I forgot there. But in combination with these two, plus stating that into the guidelines, of course, makes it a very good deal. The second thing related with the design system is working with semantics. Semantics, I can ask here who is working on Android or with Compose. Anyone? 1, 2? Okay. So the context is on Android, we have the material design guidelines who also have like some semantic, like this primary on primary, error, success, that basically allows to create a mental map on where a component belongs on the UI. So we are not stating that a text should be black or should be bold or should be italic. We just say that a heading one should be bold and black perhaps. And AI is very good at understanding that you have a heading, because basically AI is demonstrated that works very well with Markdown. And you know, Markdown has all these kind of formatted styles. So yeah, take in consideration that semantics are very, very important. Probably in web development, you have like this tokenization on the conventions also for your naming. So it doesn't matter if you use the material design guidelines or your own. This is a demo. We actually don't use this naming convention on our company, but it demonstrates a very good outcome. Okay, here comes my favorite part. It's the actual feature development. Here I didn't forget the READMEs. So we have a parent module with the README that will serve like a highway to understand what each feature does and what are basically the contracts that you can access to it. Every feature, in this case I only put user of course, has also a README that more or less has the same content but dedicated to the parent README. And the most interesting part is how basically we divide this user. On JVM, we have something called modules that basically are compiled independently, providing visibility over the implementation for each one. So I will start from the premise that you more or less understand the concept. It means that contract and implementation and resources, by default, if you don't do anything, they don't have any kind of context on the others. They don't know each other. You have to provide these dependencies on your own. So we're splitting that, makes it actually very interesting. I just set a small example on what a README for the user pattern has. We use with the interactor pattern. It's like a use case. It's like a regular wrapper over an execution of a single task. Pretty simple, and that's basically what we want to expose to the outer world, right? We don't want to express or we don't want to show implementation details to anyone, but just behaviors. So keeping up with the idea of understanding that we always want to share behavior, not implementation, that's the key. There you have like an example. What a feature module looks like, similar as I explained, on the contract, we only have interfaces. This means pure contracts, pure behavior. We just expose what kind of classes other entities or other modules can use, either the application or inter-feature communication, etc. Normally, we will only use the contract of other modules to be implemented between each others. So we will never share the implementation. The implementation, of course, is just your implementation details, network calling, caching, database, etc., etc. And resources is a special case that provides basically the dependency injection graph. So normally, there should be a man in the middle who says which is the real implementation that the contract provides, but we never want to expose that implementation to other modules. So this is a way to bypass this solution. Why? Because if we don't provide implementation onto other modules, we will never know that user repository, in this case, is the user repository implementation in a dependency from anyone else. Resources, it's basically that man in the middle who binds the implementation with it. Very convenient when you want to test and you want to basically have your resources for testing, so you can just switch the module and have your unit tests with fakes and everything is decoupled. Decoupled is the key, actually. There you go. I did like a super short diagram that basically exposes where the dependencies come from. As you can see, the contract never has dependencies over anything, so it's purely data shared across the layers. Implementation goes into the resources and resources goes into the application or into other implementation modules. As you are not aware on Gradle probably, implementation on API is a way to provide the dependencies transitively. Yeah. This means that resources can provide the contract transitively, means that by importing resources you already have access to the contract, but implementation hides the actual dependency. This means that resources won't provide visibility over the implementation. This is a very convenient part because we have a bash script that basically creates data structure for us. AI is very aware of that, and we just need to tell it that when we need a feature, he just needs to create it with basically that script. That script, but by the way, I didn't put it anywhere because you can ask AI to generate a bash script that basically copies a file structure that you prefer, and that's it. So on our case, it's dedicated on how we like it, but you can do it the way you like it. Again, this is very convenient. Why? Because you are not asking the AI to read a folder structure as you want it and copy it, but just spend few tokens to call a bash script and have a file. And the consistency is key. So the fact that we are creating all the features the same way, all the contracts the same way, all the implementations the same way, and basically all the resources in the same way, this makes a super efficient way of working with AI in the way that we are not wasting tokens. And I guess that I'm bothering you a lot on the token consuming, but when you are working several teams with a massive project, the quota expires quite fast. So basically, if you are into a bundle quota like Copilot, if you are working intensively, probably in 2, 3, 4 hours, you consume it already. And you have to wait a couple of hours or pay on demand. That's something that we don't want to do. What is modular approach? There are 3 reasons. For developers, we can be agreed that there is a separation of concerns, easy to navigate, and a good architecture. So that's something that's not new. I would sell it now because AI, but that's something that it's true now. It was true 10 years ago, and probably it was true 30 years ago or since the beginning. The second one is good for AI for what I said already. It saves tokens, it saves context, and also makes it faster. AI sometimes, the bigger the task, the slower it behaves. And of course, for teams. And this is a very critical part. We are several people working into the same project, and it's important to have consistency because improve the onboarding. We have a very, very good onboarding in the way that all the feedback we received recently is that it's very easy to get into the project up to speed and promotes ownership. That's something also that when the project grows and the teams get ownership of specific features, you want to automate more like the feature development. You have to work on a feature and then there is a dedicated team that it's working on something. You have the typical GitHub code owners that basically has like this, okay, I want to deploy on something that's affecting your team. The code owners triggers the team that basically owns that feature. It's added to the code review, etc., etc. So this helps a lot. It's more a human factor, but very convenient. I'm going on time. Okay, I will try to speed up. Then comes from the UI perspective. On Android or Kotlin multi-platform, we have pain in the ass. That's basically the presentation layer. Android has a very PT way of dealing with life cycle, so how the screen basically survives and how basically we need to deal with background, foreground, executions, and so on and so forth. Google launched a pattern called view model that basically saves the estate, but they give you freedom to development. So basically it means that you can do whatever you want, and that can grow pretty bad. I've seen really bad stuff on my past. So AI is very good at functional programming, and functional programming means trying to find the least possible state management, creating a flow that's idempotent. What means idempotent? That you can try to run a function or an intent n times, and these n times will return always the same output. So you are confident that you can basically test a function 1 million times, and for that million times, the output will be the same. And that's what we want to achieve with AI. And AI is very good at this. So we found a pattern that's very common nowadays that's called model view intent. Overall, the idea is that you are sending an object called intent that basically wraps the data that you want to perform, like let's say get the user. So you create an intent called get user, and you provide on that object the ID or whatever query data you want to provide to it. And from that, we create something called a state reduction. A state reduction is like a process where the view model internally calls tools, let's say use cases, and provides an iterative way to provide outcome. Let's say we have, I guess the time is spending so much time, so I'm going to the test part. That's one of the ways we have to test based on outcome. We have a view model that we want to test. In this case, we want to call the load user intent, whatever it is, and we expect from that intent to emit two values. The first one has username empty and is loading to true, and the second one has user John and is loading to false. This means that we clicked the fetch user, the UI starts loading because of this is loading true. It's doing some background operation, return the user, and when it returns the user, it basically turns the flag of loading false with the user. So we have like the user printed into the screen, and the loading process disappeared. And also we have like some side effect there called event that we basically trigger some analytics or something. This is a test that no matter how many times I run, this should be true. This means that every time that I load a user, or that I call load user, this stream should happen. This is very convenient because you can tell the AI or yourself how you want the view model to behave, because I expect always this behavior, no matter what's happening under the hood, that it should be true. This is one of the TDD enablers that we have. We have this pattern always working on, so we basically specify the behavior that the view model wants to, and after this test is implemented, the AI just goes with the implementation. Again, the importance is having consistency and create patterns that can be replicated 10 times or as many times as you need. I'm going on time. Good. So a summary, the key takeaways. README files, they are important. They seem for sure not, but they are. And the good thing is that you can use AI to generate the README. So, and you can just refine them as you want, larger, shorter, but they are important. The guidelines and the prompts, both are. Emphasis on the guidelines, please keep them short. But instead of instructing details on implementation, keep it onto the behavior. You have tools, please tell them to use it, and how you want them to use the tools. That's the most important thing. Then the structure. So as I said, a structure enables for pattern homogenesis. This means that you can create patterns that helps AI, but AI also helps to create patterns. This means that it's an iterative, constant process where you are doing a trial and error process where you get the feedback from the AI, you don't like the outcome, so you keep refining your prompts, and at the end you will realize that the AI behaves as you want to. It's very important. Automation saves a lot of tokens. As I explained, running bash scripts to generate code that it's repetitively, it's important to find out which of that part of the code can be automated. So it's very important, like we did with the view models, or like we did with the feature modules, and using task tools. Sorry. I added a section or a dedicated section for more specific AI toolings that I like personally, and I hope our team already likes. till now, I was focusing more onto the project-aware AI structure. Now I'm going to focus more into the AI project-less structure. As I said, AI excels at functional programming. It's weird, I know, but I am a functional programming weirdo, and I just realized that AI as well. So we are very good friends. You can think mostly on functional programming on higher order functions like input-output functions. So you don't need to go fancier onto this category theory to basically understand. It's like just focus on idempotent functions, higher order functions where we are passing functions over functions, but all of them are always meant onto input-output, stateless. So when you change your mindset to try to avoid saving a state somewhere to recover it somewhere else, all your way of thinking and the AI will also do. So I guess it's a good practice to start keeping up onto this paradigm. I just recommend it, not because I am a fan. AI learns by example, and that's something that we know since the very, very beginning of ChatGPT. You can provide a very, very long prompt with a lot of details and just have a mess up from the AI. You can have a very short prompt, but a very good example, and AI smashed it. So I recommend you to have examples for everything. Onto the example of the view model, of course, we have a templated view model, basically an abstract class, and we have kind of comment as a documentation on top of it that we explain how a basic implementation of a view model would look like. And just because of this example, we have like a 90% ratio of one-shots on view model implementation, 85. So was mentioning. Don't rely solely in guidelines. As I said, we generated this list of prompts that you saw at the beginning on the structure that are meant for a reason. They are big, but they provide a lot of context and a lot of examples. We have an SDK that it's easy for us to understand and know how it's working, but it also has some complexities under the hood that needs to be taken in consideration. So having a guideline that expresses how the SDK works, how we create phase with the SDK, how basically work towards every single corner case that the SDK can have, it's very convenient. So we use it ad hoc because not all the time we do it. Or at the end, we spend like 5-6 months to develop this SDK. We are integrating it into the application. There is a moment where the SDK is already integrated and you don't need to use the SDK guidelines every time, but perhaps when we need to implement a new feature. That's the great moment. And the template prompts. As I said, when you are asking the AI to perform a job, normally you are asking, please do something. And when it doesn't work, you say, please work. No, please make it work. That, well, can work eventually, but it's not reliable. What it is recommended is, first of all, using Markdown for explaining what you want to do. It's very convenient, so please use headers, use lists, and use headers as prioritizations. And the template, it can be whatever it works for you. For us, it's just overview, task, context, and perhaps examples if needed. We just copy paste it and just place the task that we want to put into the corresponding part. And basically, by providing a structure on how you want the AI to behave, I don't have numbers, but I'm pretty sure, like for sure, 25 to 30% better on the outcome, you will achieve it for sure. MCP configurations. I repeat again the number 1 and 2 that I already explained, so I won't go ahead. But there are 2 more that we are using, and it's very, very convenient. One, it's called Context 7. Whoever knows about it? Did you? One? Okay, cool. So Context 7 is a very, very nice MCP that became quite trendy recently. It provides up-to-date documentation on every framework that you are working on. because AI used to be trained on legacy code. The code evolves super fast, and sometimes you cannot rely on to the documentation that the AI is trained for to develop a feature on your code. Let's say Spring or Ktor, in my case, that I'm running backends on Ktor. Ktor basically launches a version every 10 seconds, so probably they launched 10 versions already. So Context 7 basically allows the AI to fetch up-to-date documentation that, of course, they have to maintain, but normally it is. And you can state on your guidelines, please read the documentation of that framework when you want to implement a feature to understand, to ensure that basically you are working towards the latest version. As you can see, the guidelines are very useful for that, so you have to keep up on enforcing the AI to use that tool. So otherwise, the behavior is quite erratic. That you cannot ensure that the tool can be called or not. It's arbitrary sometimes. And my recent favorite is Docker MCP Toolkit. So Docker has a very, very convenient way to wrap up all the MCPs that you can imagine and more into a single entry point. So basically, you just need to configure one MCP on your client, in my case, for instance, the Claude code, and run a server locally with Docker that basically provides you all the MCPs for you. We can have I don't know, YouTube transcription MCPs. All the MCPs that already stated are there. Jira integrations, GitHub integrations, PostgreSQL, Kubernetes, every kind of imaginable MCP there at a click level. You just select what you want to enable, and you just need to import this one. It's very, very convenient. There are something super nice that we are working, and basically this is experimental on our end. We are trying to also automate all the process that I've been experimenting. I explained to you recently. What is the pain point? We want to develop a feature. As I said, right now we need to provide all the prompts and all the context manually, or ideally we want to provide that context manually because of token efficiency. But sometimes you are not working alone, so this means that you don't have a consistent way of working toward the same workflow on the teammates. Everyone is doing YOLO mode on the way of working. So we were thinking, why not to create an MCP server? Because you can just ask Claude to generate an MCP server that's basically a REST API that AI understands, and that provides the same tools that we are providing manually, but as tool calls. Let's say you can create a tool call to gather project context, and basically you programmatically provide all the resources that you would do manually, because now normally we just do the same every day. You just go into the AI context, I do the AI folder, selecting the files that you need to, providing into the context window for the AI, and ask to perform whatever you want. So why not to create an MCP that provides as tool calls all this automatically, and on the guidelines you just ask to call the MCP discovery, so understanding which tool calls they have and call them appropriately, because at the end that's the benefit of the MCP, that you have discoverability and execution. So it's not that you have a REST API for AI that you can do actions, but it also provides the AI capacity to understand what to do and how to do it. That's very convenient. So we are right now at that phase when we are experimenting. Seems promising, but I didn't go further, neither I wanted. And the latest one is the Claude Code setup, because let's be honest, I guess it's one of the most developer-centered AI agents nowadays. So it feels that Claude is focusing more on developers than the others. Even the Copilot or Gemini or OpenAI, they are kind of also focusing on developers. But Claude looks like, or my feeling is that they are focusing onto the developers. They are their actual target. So we are actually doing, that's on my personal level, because we don't have Claude at the company. trying to abstract away what I explained before, but with sub-agents. So Claude has a very, very nice feature that allows you to create agents dedicated to specific actions out of the box. So you just open the CLI, you type /agent, and you keep typing what the agent wants to do, what tools do you want to have, what MCPs do you want to have, and the CLI per se works as an orchestrator. What that means, you ask the CLI to do something, it discovers that has like several kind of agents, and it makes them work in a way that creates a workflow. Let me see what I put here. Yes, so we have a specialized agent called documentation agent that basically has a task called document changes if you want, but also the orchestrator knows how to document. And we have a code review, a bug counter, and a security scanner. We have the documentation that basically can have access to the memory graph and the sequential thinking and the Git. Has dedicated prompts, or we are basically forwarding to the prompts that we have into the AI folder. So basically it reads it and knows the context. And you specify also in the prompt of that agent what this agent wants you to do as a step phases. So we know that we have the documentation, we have the code reviewer. So in this case, it has access to the GitHub MCP to fetch for a PR or GitHub issues or a commit or whatever you want. And has also dedicated markdown files as prompts to provide more context and information on how a commit works, how a PR is working, if it's well formatted, if the content is appropriate, etc. And then, of course, we have the workflow specifying what we want to do and how we want that agent to behave. We have the same for bug counter. These are just wrappers on top of what we can do manually, truly. But it's very convenient because we just automate or wrap up all these agents in sub-agents, and basically they delegate one to each other. We have the security scanner as well, so pretty similar. In this case, we have also context 7, we have the grep tooling, we have the sequential thinking, and we basically specify if we are compliant. We have this security part because, you know, it's important. We get recently also an audit, so we get a lot of feedback, and basically we took that feedback onto iterations. We were recently also in a version 2. Our audit was on a version 1, so we wanted to ensure that everything onto the version 2 of the application keep up with the same consistency on the version 1. And I guess that's it. I don't know if you have questions or we have time for questions. We don't have time for questions. So I'm sorry, but I will be around here, so feel free to grab me in.